In this video, I'm going to be looking at a specific intermolecular bonding exam question. I have three genuine student answers for us to have a look at on the mark scheme. If you're on the Crunch Chemistry website, then you can download all of this so that you have it. If not, you may just want to screenshot both the question and in a minute the mark scheme so that you know what I'm referring to. So let's make a start. Propanone dissolves in ethanol, methylbenzene dissolves in hexane. Name the strongest, we need to be clear here, type of intermolecular bond formed between them. Explain how the intermolecular bonds you have named are produced, and this question was for 7 marks, so it's a long answer question. When we're tackling these sorts of questions, the first thing that we need to consider is what type of intermolecular bonding we're talking about, and I suggest very, very strongly that we always draw a quick diagram so that we know what we're talking about. And quite often, the mark scheme, the examiner will use that diagram to credit you with marks. So let's have a look at the first one, propanone and ethanol. So propanone looks like this. We've got 2 methyl groups, CH3, double bond to an oxygen. We know that oxygen has lone pairs. Clearly, we've got a delta plus, delta minus situation here. So within propanone, I definitely have, and looking at the shape as well, I definitely have a permanent dipole. With ethanol, if I draw the hydroxyl group out first, and then we've got the ethyl group, sorry, that should be CH2, CH3, delta plus, delta minus, and I can see here that because I have got a hydrogen bonded to a very electronegative oxygen, it's not just delta positive, it is very delta positive. We're going to get a strong attraction between this hydrogen and the lone pair on the oxygen of the propanone. So even though both of these molecules have permanent dipoles, the strongest type of intermolecular bond is going to be a hydrogen bond. If we consider methylbenzene and hexane, benzene is C6H5, more commonly drawn as hexagon with a ring in it, and there's the methyl group, and hexane, we've got 6 carbons and it's simply an alkane, so CH2, 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 CH3. Neither of these molecules have an electronegative atom in them, so we've got no permanent dipoles. The strongest type of intermolecular bond is going to be instantaneous induced dipole, so instantaneous dipole induced dipole, or London forces, whichever way your exam board prefers you to talk about them. Okay, so here is the mark scheme for this question. As I said, you may want to screenshot this, or if you're on the website, then you can download it. Let's have a look at what the marking points are for. So first of all, we've already worked out the strongest type of intermolecular bond. For between propanone and ethanol, it's the hydrogen bond. And then we have 2 marks for explaining how the hydrogen bond forms. The lone pair on the oxygen of propanone is strongly attracted to the delta positive hydrogen in ethanol. You have got to be really, really clear in your answers, because if there is any confusion, the examiner will not give you the marks. If you contradict yourself, the examiner will not give you the marks. You'll see in a minute when we have a look at the actual student answers that I can tell from their answer that they think they know what they're talking about. But when you read it in the cold light of day, the answers just don't pick up the marks. So ignore the lone pair on the oxygen and ethanol. We need to be really clear here that we can get marks from a diagram. So not only is that a good exam technique for helping you sort out in your head what you're going to talk about, you may get some marks for it as well. The quality of written communication mark is also linked to the hydrogen bonding. So lone pair on the oxygen, and that we've got an attraction between that lone pair and the delta positive hydrogen on the ethanol. Moving on, when we look at instantaneous induced, it allows van der Waals forces. It would also allow London forces. Ignore ID, particularly when we are doing long answer questions about intermolecular bonding. Students are trying to save time and they use abbreviations. You never get marks for using abbreviations unless you've used the full term first. So we need to be really clear about that. Secondly, I want to draw your attention to this bit here. How you explain how instantaneous dipoles form and how that they're attracted to, or how they then form induced dipoles and the attraction between, you've got to be absolutely clear with your language. Electron movements create an uneven distribution of charge. That is the best way, in my view, the only way to say this. We are allowing the use of dipole or polar for uneven distribution of charge. Electron density changes, electrons orbiting, spinning, swirling. This is really common language in student answers and it's meaningless. So we don't want to see that, and we certainly don't want you to be writing that. So language, absolutely key here. So please take a minute to read through this answer, pause the video, have a look at the mark scheme, make your own choices first, highlight the bits of the answer that you're going to give marks for, and bear in mind everything that I have said before. So what have we got here? The strongest type of intermolecular bond formed between propanol and ethanol is permanent dipole. Well, that's not correct. Both molecules are polar, that is correct, but it's not the strongest type. So even though this is not incorrect, it's not worth a mark. You need to be very careful that we are sticking closely to the question asked when we're answering. Hydrogen bonding is the strongest intermolecular bond, and this is capable of forming as the more electronegative oxygen and the less electronegative hydrogen cause hydrogen bonds. This is the strongest type of intermolecular bond. No, let's move on. So, hydrogen bonding. Well, unfortunately, although at this point they have identified the correct type of strongest bond, they've contradicted themselves, so they don't get the mark. Let's have a look at the explanation in a bit more detail. The more electronegative oxygen and the less electronegative hydrogen cause hydrogen bonds. This is a really good example of, I think the student knows what they're talking about, they just have no ability to put it down on paper. So again, we're not seeing any marks here. There are no marks for the first part of the question. Let's move on to methylbenzene and hexane. Strongest type of intermolecular bond is an instantaneous induced dipole, correct? Going to give the marking point. Again, if your exam board talks about this type of intermolecular bond as a London force, then that would be absolutely fine. And we also know that van der Waals forces is an acceptable term here. This intermolecular bond is produced because electron clouds are continually moving, creating an uneven distribution of charge. Yes, that is very nicely said. This creates an instantaneous dipole, which then induces the neighbouring molecule. This is not very clear. Induces what? Induces a dipole is what we're looking for in the neighbouring molecule. And then it attracts. This is, actually, I'm just going to pull that out there. Although in this particular mark scheme that in itself doesn't get a mark, it's really important to say that because in lots of mark schemes it would. We've got an attraction between the delta positive end of one molecule, the delta negative of another, forming an instantaneous dipole-induced dipole bond. We don't get the quality written communication mark, so it looks like this is going to be worth 2 out of 7. I'd like to draw your attention to this here. This intermolecular bond is produced continually moving, creating an uneven distribution of charge containing instantaneous dipole. That looks to me like this has come from a perfect answer. This is something that has been learnt. This is a really good technique for some of the key concepts in A-level chemistry, where you can write yourself perfect answers, and intermolecular bonding is certainly one of those areas. Then I suggest very strongly that you do so and learn them, so that you know that when you're writing about it, you are going to pick up the marks. So not a great answer. Let's move on to student number 2. Again, pause the video, have a good read through the answer and come up with your own judgment on how many marks you would give this. Unfortunately, this student can't spell the word dipole, and that in itself is raising alarm bells. Bonds are formed when electrons in an atom are unbalanced. Well, unfortunately, that is just drivel. This induces a dipole in a, I'm going to pretend that they've spelt it right, in a neighbouring atom, because the negative electrons attract the neighbouring atom. Now, again, we've got to be really careful here. At A level, this is not incorrect, but in the context of the sentence, the student clearly has no idea what they're talking about, so I'm not going to award any marks for it. The bonding is very weak, easily broken. Instantaneous dipole, induced dipole. This would be methylbenzene and hexane. It's possible, if it were a really nice examiner, that they would give a mark for correctly identifying the type of intermolecular bonding between these two molecules. However, the fact that dipole is misspelt throughout the entire answer makes me think, oh, not convinced. Hydrogen bonding is stronger than the bonding from instantaneous dipole. Induced dipole is still very weak. This bonding is present in propanone and ethanol, so that would get a mark. So it's possible that this is worth 1 or 2 marks out of 7. Okay, so let's have a look at student answer number 3. Between propanone and ethanol, a hydrogen bond can form. That is the strongest type, so we're happy with that. Hydrogen bonds, yes. These bonds form as the hydrogen in the hydroxyl group of ethanol becomes partially positive charge, because it's less electronegative than oxygen, and it's attracted to the lone pairs of oxygen and propanone, creating a hydrogen bond. So we have everything we need here. This essentially is the perfect answer for explaining how hydrogen bonds are formed. We've got the very delta positive hydrogen. That's identified in the correct molecule, ethanol. That it's attracted to the lone pair of oxygen, not just oxygen, but to the lone pairs on the oxygen in the propanone. That's great. And we also get the QWC mark because it's all nicely put together there. Only instantaneous bonds can form between methylbenzene and hexane. That is not the correct name for that type of intermolecular bonding. These arrive when random electron movement causes a temporary polarity in the molecule. According to the mark scheme, that would be allowed, so we can give a mark there. This induces a partial charge in the nearby molecules under weak intermolecular forms. Partial charge isn't enough. We need to be calling it a dipole because it's this uneven distribution of charge across the molecule. We've got the delta plus, the delta minus, and hence the attraction. So we are going to give the QWC mark. So QWC, yes. So 1, 2, 3, 4, 5. This answer would be worth 5 out of 7. However, I think if you combine the best parts of student 3 and the best parts of student 1 answer, you're going to have the perfect answer. So have a good look at these, have a look at the mark scheme, write your own perfect answer for this question and commit these little bits to memory, because it is the best way to be ensure that you can write very quickly about intermolecular bonding and pick up all the marks. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the description below, it'll take you straight to Crunch Chemistry School, where you can access my free maths skills course, complete tuition, and worksheets designed specifically to build your confidence and stretch you. Together we can do this.